Hello, my name is Dixit Amalya. I am from BTech IT 7 SEM. Today's topic is basic understanding of Jenkins. Jenkins is an open source automation server used primarily for continuous integration and continuous delivery in software development. It helps automate tasks like building, testing, and deploying applications, allowing developers to detect and fix issues quickly. Jenkins supports numerous plugins, making it highly customizable for different development workflows. Oh, Jenkins pipeline. First step, checkout. The checkout step is where Jenkins retrieves the latest version of control system like Git, GitHub, or Gitbucket. This step is crucial as it is ensure that the most up-to-date code is used for the next stage of the pipeline. Build. Build stage is compiles the source code into executable artifacts like binary, Docker images, or other deployment formats. This process may involve installing dependencies, resolving libraries, or compiling code into language such as Java, Python, or JavaScript. For example, in Java project, Jenkins might use Maven for or Gradle to build the code, while for a Node.js project, it may run npm install and npm build. Third stage is test. In the test phase, Jenkins run automated tests to ensure that the new build code behave as expected. This can include unit test, integration test, functional test, or even UI tests, depending on the project's requirement. For example, Jenkins might use JUnit for the Java test, Jest for JavaScript, or PyTest for Python. If any test fails, Jenkins halts the pipeline, allowing developers to fix the issue before proceeding. Staging. The staging environment is a replica of production, where the application is deployed to test under the production-like conditions. This step allows further validation of the application's performance and behavior before making it available to end users. For example, Jenkins might deploy a Docker container of application to a staging server. Here, stakeholders can manually verify the app or run acceptance tests. Production, or the last stage of Jenkins pipeline. Once everything is verified, the production stage involves deploying the application to the live environment where real users interact with it. This stage typically happens after all the tasks past the end approved are given. For example, Jenkins could trigger Kubernetes to deploy new microservices to production or update a cloud environment like AWS or Azure with the latest version of the app. Edge. The edge environment refers to an extension of development process where services or applications are deployed closer to end user, often at the network edge. Edge computing involves processing data at or near the point of origin rather than relying on the centralized data center. For example, Jenkins could deploy microservices to edge servers located near users, which is beneficial for latency sensitive applications like video streaming or real-time analysis. In Jenkins, there are two types of pipelines, declarative or scripted. Each has its own syntax, structure, and use cases. For declarative pipeline, syntax is very simple and more structured syntax. Typically consists of predefined set of sections like pipeline, stages, and steps. Easy to use, easy to read and write, making it more user friendly for those who new to Jenkins. Structure enforces a specific structure, require you to define stages and steps in a clear manner. Automatically handle certain aspects like agent allocation. Error handling provides built-in error handling capability using post blocks for action based on success, failure, or other condition. Use case the best suited for the simpler pipeline where a clear sequence of tasks is required. Here is the example of declarative pipeline. Scripted pipelines. Syntax is more complex compared to declarative pipelines. Syntax based on Groovy scripting offers greater control and customization, but requires more familiar with Groovy. Does not enforce a specific structure, allowing you to create pipelines in any way you choose. It can include loops, conditional, and other groovy features for dynamic behavior. Error handling requires manual error handling using try-catch blocks or other groovy constructors. Use case best suited for complex workflow that requires advanced scripting, dynamic behavior, or custom logic. Here is the example of scripting pipeline.